Hello, my name is Akshaya Vitla. I'm currently studying for an MSc in Advanced Computer Science at Cardiff Metropolitan University. This presentation is the part of a CMP 7001 Advanced Programming Module. For this program, I have mainly focused on LMP technologies where I designed both a user case diagram and a class diagram to model a repair management system. This diagram helps illustrate how different users, such as customers, technicians, and administrations, interact with the system. These interactions include tasks like booking repairs, assigning jobs, sending notifications, and generating bills. The system design also applies course object-oriented principles, including inheritance, and use the strategy design pattern to manage different types of notifications like emails and SMSs. So let's move into the project. Here is a quick review of what I will be covering in this presentation. I will start with a brief introduction followed by the use case module and the class diagram that represents the systems and the instructions. So this is my class diagram, and this is my use case diagram. So the project will be based on this. So this here I will be applying polymorphism and desired patterns, particularly focusing on notifications, and I will touch on exception handling is used in the system. After that, I will move to a discussion of the module objectives, highlighting some of the design issues I have encountered, and finally wrap up the conclusion summary, the key takeaways. So the use case diagrams. This slide gives a summary. So this is my use case diagram. So the system is mainly built around three primary actors like customer, admin, and technician. There's customer, admin, and technician. So then each actor interacts with the system with different ways. The customer can book, repair, update their details, and view notifications sent by the admin. The admin handles every jobs assigned by assigning repairing jobs, sending out notifications, and processing bills. Meanwhile, the technician is responsible for updating uh, repair status, reviewing and assigning jobs, and completing assigned tasks. The use case diagrams also include exceptions handlings like no repair booked exception, no repair booked exceptions. And coming to the class diagrams, designing class diagrams is one of the main tasks to start building application. Here are the list of classes and interfaces I'm going to use in my application. So this is my class diagram, which I have built. So we'll go to it like what I have used in the class diagrams, and let go into the brief. So this is my class diagram overview, which I have used the classes. So this slide represents a class diagram that defines internal structure of the repair management system developed from the LMP technologies. There are the classes and interfaces I have used in my application. Uh, and also at the center of the design, the abstract. This is the abstract user class, which acts as the base of the main class roles. It is extended by three, which is customer, admin, and technician, each which inherits shared properties and behaviors for the user class, such as ID, contact details. The customer class is responsible for actions like booking, repair jobs, viewing bills, and updating personal details. The admin manages users, assigns repair jobs, and notifications over through the technician classes handles repair assignments, update job status, marks repairs as complete. Moving forward to the repair job. So this is a repair job. Here is the class is center of the system's operation. It is maintains information about the repair status, assigned technician, and associated equipment. Then moving to the bill, class is closely tied to repair job and customer. It stores payment details and bill status, calculates charges. The user composition here suggests that a bill cannot exist independently without a repair job. So it will always connect to the repair job. Next, we have a equipment class, which represents the physical items needing repair. This class could include fields such as equipment type and description of the issue and possibly warranty details. So then the supplier are handled through the supplier. So this is moderately connected using a stock and add suppliers interface, allowing the system to attract suppliers and inventory logic that makes the system more extensive and easier to maintain. On the highlights of the diagram is the use strategy design pattern. Is the main like it is the main strategy design pattern. I have implemented notification strategy. So this is notification strategy interface, which is used notification sender class to send messages. Then this design pattern allows multiple notification methods like SMS customer and SMS notification, making the system more flexible to open to the future enhancements. Finally, even though not shown as content in classes in this design, the system also accounts for exception handling such as no repair booking and no payment exception to ensure smooth and error control. Overall, this diagram reflects structures, scalable and object-oriented approach to designing the system. It combines principles, inheritance, compositions, attractions, and design patterns, making design both reboost and affordable to future changes, adaptable to future changes. So then in this project, I have used polymorphism in few key points, making the system more cleaner and more flexible. The first time I have used the user class I have created in the Blaze class using user that is extended to build admin and technician. Then with polymorphism, I can treat all the user objects in the code, automatically use the right version depending who logged in, which helps to keep the code simple and avoids writing the same logic multiple times. Second example in the notification system. In the notification system, so and which have different versions like email notification and SMS notification. No matter which one is used, the system just calls the methods like send notification, and it works all the types. Overall, the using polymorphism made the application more organized and maintainable and flexible, especially as it grows changes in the future. In this project, I have also used few design patterns to make the system more flexible and easier to manage. The first one is a strategy pattern, which is used for sending notifications. I have created more common interface called notification strategy. Here, I have used notification strategy and then build different versions like email notification and SMS notification. The system picks the right one at the runtime depending on how the user wants to be notified. This makes it easy and add new notification types later without changing existing code. Next, this kind of template pattern using inheritance. I have base class user ID and it is extended by like this customer, admin, and technician. They all are they share like common features, but also have different own specific behaviors. This helps to avoid repeating code and keeps things organized. I have also used the inheritance called stock and suppliers to manage stock and suppliers to manage the to make it easier and to build the, for example, when a repair a job is updated, the system could automatically notify the customer for a technician without needing manual input. So this pattern would help the system react to changes to the real time every time everyone updated automatically. So these patterns will help the system stay clean and extend right to real world use. So I have also used XML handling for smooth flow of application, and I have used both built-in and user-defined exception to smooth flow of application. I have also used both built-in and custom exceptions to handle errors and exception situations in a clean and user-friendly way. Starting with building exceptions, these are commonly like causes like invalid inputs, missing data, or type mismatches. For example, if a user enters an incorrect value or leaves a required field empty, exceptions like value error, type error are raised, and the system responds with a clear message instead of crashing. In addition to that, I created a couple of user exception handling to handle specific situations related to the business logic. So one of them is, oh sorry, one of them is a no repair, and the other one is null pointer exception. So this is used when the customer tries to check, update a repair job that hasn't been booked yet. Instead of failing silently or showing random errors, the system raises these exceptions and give the user a helpful message so that he can rectify what is the error. So then a discussion of my like what the decisions uh, in my decisions I have faced. So here is while working on this project, I have faced a few challenges, especially around organizing the structure and logic of the system. One of the first issue while dealing with the complex relations between classes, for example, how a customer connects, repair, and how those jobs relate to billing and technicians. So this helped to avoid confusion and made development smoother. After challenging was deciding how to handle notification. I explored a few options before setting on the strategy design pattern, which allowed me to keep the logic flexible and easy to extend. Then, lastly, I wanted to avoid writing repetitive code, especially a similar logic appeared across different types. To fix this, I used inheritance and polymorphism, which helped me to keep code clean and reusable. And the importance of this design planning, applying object-oriented principles in the real world context. And then a discussion module. In this module, I learned the fundamental concepts of object-oriented programming. I now understand how classes and objects work, basically how we can model real world things in code. I learned how use methods to define behavior and how constructors helps to initialize our objects. And another key part was learning UML class diagrams. They helped me visualize how different parts of a system connect, which made designing software feel much more structured. We covered exceptional handling too, which we all about writing code that can deal with the errors without crashing. So overall, this module helped me build a strong foundation in OOPS and software design. So my this is my conclusion. I want to conclude that this presentation I have built a strong foundation in object-oriented programming, and I have also learned how to apply classes, objects, methods, and constructor gain particular skills in UML and class diagrams, and also exception handlings for robust systems, designing a complete real-world repair management system. So here is what I have learned. Thank you for watching.